So, have you ever tried to balance a pencil perfectly on its tip?
Oh, yeah. It's basically impossible.
Right. But you hold it there, perfectly vertical, and for this, split second, it feels completely miraculously stable.
Yeah, until you let go.
Exactly. You take your hand away, and it just stands there for a millisecond. But then, I don't know, a microscopic shift in the air in your room, or a tiny vibration from a truck outside.
Or even just the unevenness of the graphite itself.
Right, exactly. It takes over and it falls. And the wild thing is, no matter how many times you do it, you can never predict exactly which way it's going to drop. I mean, when a pencil falls, it is just pure chaos.
Yeah, it looks like this static, solid object, but mathematically, a balanced pencil is really just a system waiting for an excuse to fall apart.
Wow.
The system is so incredibly sensitive to its starting conditions that, the slightest breath changes its entire future.
And according to the eclectic and honestly deeply provocative notes of a theorist named Guy Lakeman, human society is currently that pencil, just vibrating right before the drop.
Yeah. It's a terrifying thought.
It really is. So welcome to the deep dive. Our mission today is to unpack Lakeman's incredibly dense, wildly sweeping stack of notes and models, which are all gathered under the source title Guy Lakeman Insight Maker.
Right.
We're going to attempt to map out what he sees as basically a comprehensive theory of everything, specifically focusing on societal collapse, and more importantly for you listening, survival.
And I have to say, it is quite the collection to sift through. Lakeman draws these massive sweeping lines between, the mathematical spin of elementary particles and global climate change.
Yeah, the jumps he makes are wild.
They really are. He connects the failure rate of industrial factory machines to the loss of public trust in local governments. He's basically looking for the universal physics of failure.
And he does not hold back. I mean, you'll be reading this deeply complex breakdown of chaotic equations, and then suddenly, bam, you're hit with an intense, unfiltered political rant about the flaws of modern democracy.
Oh, absolutely.
There's even this one moment where he's explaining the standard deviation of a Gaussian distribution, right? The bell curve.
Oh, the upskirt joke.
Yes. He throws in this completely bizarre joke about how normal variables are mathematically called a normal deviate, but people who enjoy taking upskirt photos are called deviants and have an entirely different variable distribution. It's a completely wild ride.
It definitely keeps you on your toes. And, my role today is to sift through that exact whiplash. We're going to connect the dots here, find the underlying mechanisms in Lakeman's mathematical models, and explain why these disparate, sometimes jarring ideas actually matter to your understanding of how the modern world functions.
Exactly.
You really want to look at how these systems are built and precisely how they might break down.
Okay, so let's unpack this from the ground up. Lakeman's entire worldview seems completely anchored in chaos theory and something he calls the logistic map.
Right.
Now, you mentioned the pencil on its tip earlier, but Lakeman also uses the example of a ball placed exactly on the crest of a steep hill or a rock dangling on the end of a piece of string.
Yeah, those are classic illustrations of the butterfly effect.
Okay.
The formal term in physics is actually sensitive dependence on initial conditions. The core idea is that in certain dynamic systems, a tiny, almost immeasurable change at the very beginning results in massive, violently unpredictable differences later on.
Wow.
And Lakeman is utterly obsessed with how this mathematical truth applies to human society. To prove it, he relies heavily on that logistic map you mentioned, which is a famous mathematical concept popularized in a 1976 paper by the biologist Robert May.
So rather than reading out a string of algebra, which is awful for audio, let's look at the shape of this math.
A good idea.
This map is basically an equation that shows how a population grows. It's like a tug of war. On one side, you have a massive growth rate, right? The accelerator. On the other side, you have the absolute maximum carrying capacity of the environment, the brake. So the math just calculates the collision between the accelerator and the brake.
That is the perfect way to visualize it. The formula essentially calculates the population of a new generation based on the old generation, factoring in how fast they breed versus, how much food is actually left.
Okay, that makes sense.
And Lakeman sets up a specific simulation in his notes. He sets the maximum carrying capacity, the absolute limit of the environment, at 1 million, representing Nmax, and he sets the growth rate, incredibly high. He puts it at 3.
All right, let me try to make this relatable for you listening, because stare it at on a page, it's really just numbers.
Go for it.
Think about a viral social media trend. At first, it's just you and a few friends doing a specific dance on video. The growth rate is huge. Everyone who sees it copies it. It grows exponentially, doubling every day.
Right. Unchecked growth.
Exactly. But eventually, you run out of new people on the app who haven't seen the dance yet. You hit the platform's user limit. That user limit is your carrying capacity.
Yep.
And here is where the math gets crazy. The trend doesn't just peacefully stop growing and level off into a nice flat line. As it hits that wall, the system starts behaving wildly.
Yeah, it fractures.
Right. You get backlash videos, irony videos, people doing the dance ironically while scuba diving. The trend just completely splinters.
Because the feedback loop forces the system to overcorrect. What the logistic map proves mathematically is that when a system with a high growth rate approaches its absolute limit, it cannot gracefully slow down.
The momentum is just too much.
Exactly. It shoots past the limit, starves, crashes down below the limit, and then tries to grow again. It oscillates wildly. It falls into chaotic turbulence.
Man.
And Lakeman's overarching point here is really the foundation of his entire philosophy. If simple mathematical models prove that unchecked growth eventually hits a wall and turns into chaos, what happens when you run that exact same math on the entire planet Earth?
Right. Which brings us to Lakeman's expansions of the World 3 model.
Yes.
Just for context, World 3 is a highly detailed, very famous computer simulation of human population and economic growth that looks all the way from the year 1900 deep into the future.
And Lakeman has built out his own variations of this model, spanning from 2014 to 2020.
And the metrics he pulls from these simulations are alarming, to say the least.
Oh, they're terrifying. Lakeman uses these software models to calculate the exact limits of our physical environment. He shows that humanity actually passed the sustainable carrying capacity of our arable land, land that can actually grow food, back in 1990.
1990?
Yeah. And according to the data he feeds into World 3 today, we're currently operating at 1.5 times over what the Earth can sustainably support in terms of resources.
That's just wild. And he paints a very bleak picture of the cascading effects of this overshoot. He's not just saying, oh, it gets hotter.
Yeah.
He maps out the actual mechanics.
Right, the physics of it.
Yeah. He talks about the albedo effect melting the polar caps. The albedo effect is essentially reflectivity. White ice reflects the sun's heat back into space, but as it melts, it exposes dark blue ocean, which absorbs the heat. It's a vicious cycle.
Yeah, a massive feedback loop.
And he models how this massive heat absorption shifts the northern jet stream, which then extends cyclone activity around the Hadley cells, these massive atmospheric circulation patterns near the equator.
And he even makes a point that global weather isn't just this homogeneous, even blanket warming up at the exact same rate everywhere.
Right.
It's actually a collection of localized heat bumps. He argues these are directly driven by the sheer population density of massed urban conurbations. We call them urban heat islands.
The cities, basically.
Exactly. The concrete, the cars, the lack of trees. Millions of people crammed together create these physical anomalies in the atmosphere that disrupt weather patterns thousands of miles away.
But here's where it gets really interesting to me and where I kind of have to push back a bit on the sheer inevitability of this doom.
Okay, let's hear it.
In Lakeman's own simulation notes, he talks about using sliders to experiment with the outcomes in the World 3 software.
Right.
He suggests tweaking the initial amount of non-renewable resources or sliding up new, low birth rate, highly aggressive environmental policies starting in the year 2015. So if he has the data, are we just waiting for this global system to break, or do his own sliders actually offer a way out?
It's the crucial question to ask when looking at these simulations. What Lakeman finds is that even if we applied those strict ecological policies, even if we slide the birth rate down and the green energy up, the simulation still shows a deeply fractured survival.
Wow.
Yeah. Some dispersed populations can be stabilized, but the major cities still suffer catastrophic collapse.
Why the cities specifically?
The reason why brings us to Lakeman's core economic thesis. He argues that the existing global capitalistic growth paradigm is totally fundamentally flawed because it relies on a concept he calls infinite bigness.
Infinite bigness. Basically the idea that economies, corporations, and cities must always grow forever, every single quarter, or they're considered failures.
Exactly that. But we just established with the logistic map that infinite growth in a finite space always leads to chaos.
Right, the wall.
Yeah. Lakeman argues that forcing mandatory growth on already unstable, overpopulated urban systems is the equivalent of flooring the gas pedal while driving toward a cliff.
Yeah, that's a dark image.
It eventually breaks the fundamental link between supply and demand, leading to what he calls turbulent, chaotic destruction. And when that catastrophic failure happens, the controls of the system are thrown into a situation that can never return to its initial conditions.
It's permanently altered.
Exactly.
Okay, I can easily visualize a physical environment breaking under pressure. Arable land turns to dust, ice melts into the ocean, cyclones hit the coast. But how exactly does a human system, like a society or an economy or a government, actually break down?
That's a great question.
Lakeman uses a really fascinating concept from reliability engineering to explain the mechanics of societal collapse, doesn't he?
He does. He applies the bathtub mean time between failure risk curve. Usually it's just called the MTBF curve.
MTBF, right.
It's an engineering formula, usually FT, 1E, used to predict exactly when physical equipment, like a factory robot or an airplane engine, will break down. But Lakeman takes the conceptual shape of this curve for machine failure and applies it to social policies and political institutions.
So let's look at the shape of this bathtub because it really explains how we experience the world.
Yeah, so the curve has three distinct phases, making a U shape or, well, a bathtub.
Okay.
The first is early life. When you first build a system, the failure rate starts high but decreases rapidly. Think of it as the factory testing phase. The weaker parts break immediately, you replace them, and you are left with a rigorous functioning machine.
Makes sense.
The second phase is useful life. This is the long, flat bottom of the bathtub. Failures still happen, but they're totally random, the rate is low, and it's highly predictable and manageable.
So this is the era of stability.
Yes. But the final phase, the right side of the bathtub curve shooting steeply back up, is wear out. The parts become old. The friction of daily operation grinds down the gears. The system begins to fail at an accelerating, compounding rate.
And Lakeman argues our societal policies are currently deep in that wear-out phase.
Deep in it.
He specifically calls out the concept of ancient Greek democracy, pointing out that a system designed 3,000 years ago for a very small population of landowners simply cannot be applied to a hyper-connected, globalized world of billions without massive system-breaking friction.
And Lakeman makes a brilliant conceptual leap here from engineering to psychology.
Oh.
He says the mathematical inverse of this accelerating failure curve is trust time.
Trust time.
Yeah. As the failure rate of the system goes up, the exact inverse is a direct, measurable loss of public trust. When the infrastructure stops working, society moves into deep suspicion and a complete lack of confidence in the people meant to run the machine.
Okay, I love this. Imagine you own a reliable old car. During its useful life phase, you trust it implicitly. You drive it to work every day. You don't even think about it.
Sure.
But when it enters the wear-out phase and the transmission slips on a Tuesday and then a week later the alternator dies and then the radiator cracks, you don't just replace the parts. You lose the psychological trust required to take that car on a long road trip.
Oh, that's exactly it.
Even when the mechanic tells you it's technically fixed, you grip the steering wheel waiting for the next breakdown.
Yeah, that psychological scarring you just described is the perfect bridge to the next concept Lakeman explores. Hysteresis.
Hysteresis.
Right. In physics, hysteresis is the lost energy associated with delay. It basically means a system's future state is dependent not just on its current environment, but on its past trauma.
So the system has a memory.
Exactly. It can be permanently deformed by what it has been through, like a rubber band that's been stretched way too far and never quite snaps back to its original size.
And he uses a really compelling economic example to ground this, if I remember correctly.
He does.
He explains how an economic recession isn't just a temporary dip on a stock chart that eventually bounces back.
Right.
A recession forces factories to close, resulting in mass long-term unemployment. And the longer people are unemployed, the mechanics of their lives actually change. They lose specialized skills, they drain their savings, they become demotivated and deeply disillusioned.
Furthermore, the institutions themselves change. Employers start to view a 3-year gap on a resume as a red flag.
Yep.
So even when the economy eventually booms again and the stock market is hitting all-time highs, those affected workers don't share in the prosperity. The system has permanently left them behind. The economy is scarred by its own history.
The trust is gone, and the capacity of the workforce is fundamentally altered.
Precisely.
So we have this compounding narrative. Slow decay of old institutions pushes us into the wear-out phase, which erodes our trust in the system, and past trauma leaves permanent scars via hysteresis. But what happens to a weakened, overcapacity, heavily scarred system when it is hit by a sudden, massive shock? Lakeman's notes dive into what is arguably the ultimate stress test for humanity: infectious disease.
Yeah, Lakeman spends a lot of time mapping out epidemiological models, specifically the Kermack-McKendrick-Sur model.
Okay, sir.
Yeah, Sur stands for the 3 states a person can be in during an outbreak: susceptible to the disease, infected by it, and recovered. Or removed, which mathematically can mean recovered with immunity, or unfortunately dead.
What's terrifying about reading these models is how little it takes to kick them off. Lakeman notes that the entire massive simulation requires just a pulse of a single infected person at time 0 to initiate chaotic global spread.
And he tracked real-world biological shocks to test these mathematical bounds. He analyzed SARS, noting how a relatively small outbreak of 8,000 infected people over 9 months triggered massive systemic panic.
Wow.
He looked at MERS from 2012, highlighting how a virus can embed itself in a system, still killing patients 8 years later despite advanced treatments like interferon. And his notes actually capture his early real-time tracking of COVID when it had just reached 150,000 cases. He plotted its trajectory to show how its high-speed mass infection numbers were mathematically guaranteed to reach pandemic proportions.
It's eerie. He uses some really heavy terminology here, too, mapping these out using agent-based modeling and Erlang distributions.
Yeah, let's break those down. An Erlang distribution is essentially a mathematical way of mapping a waiting room where delays pile up.
Okay.
If you imagine a hospital where every patient needs a slightly different amount of time with the doctor, the Erlang distribution predicts exactly when the waiting room will overflow into the streets.
Ah, I see.
And agent-based modeling is like looking at a massive game of The Sims.
Oh, I love that analogy.
Right?
Okay.
Instead of looking at a population as one big blob, the computer simulates millions of individual digital people, giving them rules like going to the grocery store, going to work, coughing on a train, and watches how the chaotic interactions unfold.
So using those models to map out what he calls a pandemic apocalypse containment strategy is just almost chilling to read.
It really highlights how delicate the bathtub curve of our society truly is. In his notes on this RR model, Lakeman demonstrates a critical mechanism. The difference between permanent immunity and waning immunity.
Right.
If a population gets a virus and becomes permanently immune, like herd immunity, the math eventually stabilizes.
Okay.
But if he introduces waning immunity, meaning people can catch it again in 6 months, it changes the entire state space of humanity.
Wow.
Single biological pulse interacting with waning immunity prevents the system from ever settling. It throws us right back into the unpredictable, oscillating chaos of the logistic map we started with. Just endless waves.
So let's take stock of the board here. The math proves that forced growth hits chaotic limits. Our environmental models calculate we are operating 1.5 times beyond planetary carrying capacity. Our governance institutions are sitting deep in their wear-out phase, drastically bleeding public trust. And inevitable biological shocks can upend the entire global economy with a single microscopic pulse.
That's a lot.
It's a lot. So how equipped are we to navigate this? Well, according to Lakeman, our current governance system is unequivocally unqualified to handle it.
Which brings us to the most aggressive and undoubtedly the most controversial part of Lakeman's notes, his absolute critique of modern voters, the fundamental flaws of democracy itself, and his proposed solution, which he terms the bubble theory.
Yeah, he leverages some incredibly aggressive statistics here to make his point. Lakeman claims that 85% of the population has an education qualification level of a 12th grader, roughly a 17-year-old or lower.
Right.
And he bluntly states that the statistical chance of finding someone with any sense is about 1 in 6.
It's harsh.
It is. Based on this, he defines modern democracy as a system where a group allows the decision-making ability of a teenager to choose unqualified misrepresentative, who then make complex scientific and economic judgments on policies affecting millions.
And he uses a vividly absurd analogy to drive his disdain home. He says modern voters are like children who would happily vote for King Kong to run the country.
King Kong.
Yes. Why? Because even though King Kong routinely swats fighter jets out of the sky and has no functional brain cells to govern with, he has a nice smile and offers little girls sweets.
Oh my God.
Yeah. Lakeman argues that governments actively exploit this dynamic, using what he calls bad parenting techniques, pandering to the pleasure principle with short-term economic sugar highs to control the populace, while purposely making higher analytical education more difficult to access.
Okay, we need to be clear here. For everyone listening, we are purely exploring the ideas contained in Guy Lakeman's text. We are not endorsing these viewpoints, but impartially reporting how he views the world. And Honestly, I have to push back intellectually on Lakeman right here. Isn't it incredibly reductive and frankly elitist to dismiss the life experience and agency of 85% of the population just because they don't hold advanced degrees in chaos theory?
It's a very fair critique.
Right. I mean, a factory worker or a farmer has a deep practical understanding of how their local economy works. Lived experience has its own deeply valid, complex intelligence, doesn't it?
That is a fundamental and necessary critique of his position. But to understand how Lakeman's models resolve, we have to look at his underlying, almost mechanical logic. He actually addresses that exact counter-argument about lived experience in his notes.
Oh, he does?
He does. He states, quote, "Experience means little if you don't have enough brain to analyze it," end quote.
Wow.
Yeah. To Lakeman, modern democracy fails not because people are inherently bad, but because voters cannot possibly hold the complex implications, the long-term mathematical context, and the cascading global effects of the policies they are voting on in their heads.
Because the system is too big to comprehend?
Precisely. To him, the ultimate disease tying all of this together, the economics, the melting ice caps, the political dysfunction, is that concept of infinite bigness.
Trying to scale a tribal human system to govern 300 million people.
Yes. And his proposed cure for infinite bigness is the bubble theory.
Bubble theory?
Yeah, he leans heavily on the concept of Dunbar numbers.
Ah, right.
Dunbar's number is a suggested cognitive limit on the number of people with whom one can maintain stable, meaningful social relationships. You know, knowing who each person is and how every person relates to every other person. Anthropologically, it's usually cited around 150 people, the size of an ancient hunter-gatherer tribe.
Okay.
Lakeman argues that the human brain is simply not physically wired to empathize with or govern a million strangers. Therefore, we must abandon infinite bigness and force our human systems into finite, limited-size working capacity containers.
You're basically dismantling massive globalized nation states into hyper-local, tightly controlled bubbles. He specifically outlines a vision of self-sustaining villages or localized communities. He talks about setting them up with balanced profit and loss centers, meaning everything they consume, they must produce or afford locally.
Right. He firmly believes that only by keeping the population size of the decision-making body small enough to fit within human cognitive limits can we ensure ecological sustainability, rebuild the trust time of the bathtub curve, and prevent the chaotic turbulence of societal overshoot.
Man, it is a profoundly radical argument about the physics of limit.
It really is. The physical limit of the Earth's carrying capacity, the mathematical limit of our economic structures to grow infinitely, and ultimately the biological cognitive limits of human beings to manage complex systems without succumbing to chaos.
We have covered incredible ground today. We started with the simple, delicate image of a pencil balancing on its tip and followed the undeniable math of chaos theory and the logistic map all the way to the collapse of the global capitalistic paradigm.
Yeah, quite the journey.
Seriously. We looked under the hood of the World 3 model to see the mechanics of environmental overshoot. We mapped the decaying trust of the MTBF bathtub curve. We felt the permanent psychological scarring of hysteresis. And we tracked the viral math of pandemics.
And it all culminated in Lakeman's radical proposition to dismantle modern democracy into hyperlocal, cognitively manageable bubbles.
It forces you to look at the invisible structures holding up your daily life and ask exactly where we are on that failure curve.
It absolutely does.
And that leaves us with a final thought I want you to mull over as you go about your day. If Lakeman's bubble theory and his strict reliance on Dunbar's numbers suggest that human beings are fundamentally biologically only built to manage small, finite communities of about 150 people, what does that mean for your digital life?
Oh, that's a great question.
Right. Are the algorithms that connect you to millions of strangers online every single day? An environment built entirely on the premise of forced, infinite bigness, actually pushing your own personal psychological system into the exact turbulent, chaotic destruction that Lakeman warns about on a global scale.
It certainly raises an urgent question about the architecture of the digital systems we volunteer to be a part of every time we look at our phones.
It absolutely does. The math applies everywhere. Thank you so much for joining us on this deep dive into the Insight Maker's notes. Stay curious, keep your balance, and we'll see you next time.